Okay, so in this video we're going to calculate the Taylor polynomial for 5 terms at the point 1 for the function e to the x. So when we're calculating the Taylor polynomials, we need to know 3 important things. The number of terms, so in our case it's 5. The point at which we're calculating it, so in our case it's 1. And which function is, well, it's e to the x. So degree n, that is n is 5 at point A is 1, and the function is e to the x. And here we've got the generic formula for Taylor polynomials, which is along the bottom there. And then we can see here, just to explain what it all means, f of a just means the value of the function at that point. So in our case it's 1. The value of the function at 1, so a is 1, so f of 1. The first derivative divided by 1 factorial times x minus a, so in this case would be x minus 1 to the power of 1. Then we've got the second derivative calculated at the point 1 divided by 2 factorial times x minus 1 squared. And then the next one is the third derivative at the point a, which is 1, divided by 3 factorial x minus a, which is x minus 1 cubed. So you'll see there's a pattern forming here. So we've got 2, 2, 2, 3, 3, 3, 4, 4, and 4, 5, 5, and 5, and so on and so on. So that's our generic formula for Taylor polynomials. So the next thing we need to do is to calculate all these derivatives. And we'll do it one stage at a time. So we do calculate the derivatives, and then we'll start substituting some formulas in, and we'll make a little table up. So here's how we do it. So differentiate the function e to the x 5 times and calculate the values of each derivative at 1. So the function is e to the x, and f of 1, so that's e to the power of 1, is basically e. And e is equivalent, or similarly equivalent to, 2.71828. Now this decimal places will go on and on and on and on many hundreds and hundreds of times. It just never ends. But what we can say is it's approximately 2.71828. But all we do when we're working with e, we just write the number e, or the letter e. We just write little case e. So differentiating 5 times is nice and easy, because no matter how many times you differentiate e to the x, you'll always get e to the x. So all these are e to the x. Then the value is 2.71828 approximately, which is e. Then the first derivative is e, second derivative is e, third derivative is e, fourth derivative is e, and the fifth derivative is e. So that's all pretty straightforward. So we can go straight ahead now and just go straight to our Taylor polynomial formula, start substituting some values in. So I've substituted the n's for 5 and the a's for 1. So the value at 1, derivative at 1, second derivative at 1, third derivative of 1, fourth, fifth, same. And then I put x minus 1, which would be to the power of 1, but we don't need that. X minus 1 squared, x minus 1 cubed to the fourth, and x minus 1 to the fifth. Okay, so next stage, we can start plugging in the values of our derivatives. So where we've got the first derivative, e, we can just put an e in there. E over 1 times x minus 1. So for example, the fourth derivative, we've got e. So we substitute here, e divided by 4 factorial times x minus 1 to the 4. 4 factorial is 1 times 2 times 3 times 4, which is 24. So all these here, these numbers on the bottom here, we've got 1, 2, 6, 24, and 120. So, next stage. So substituting all these values in. So the value at 1, which is how we get to this stage, was e. So just go up the page a bit again. So f of x, f of 1 is e. So that's why we got e there. Then the first derivative was also e. So e divided by 1 factorial is e divided by 1, which is just e. So it'd be e times x minus 1. You could write e times x minus e, but to multiply out the brackets, but it's standard just to write e times x minus 1. It would be the equivalent value, but it would be no need to do that. So the second derivative is e, which we got here, and e times x minus 1 squared over 2 factorial. So to get to that one, we go to here. So the second derivative is e divided by 2 factorial times x minus 1 squared, and that explains this one. And again, No need to multiply out all the x minus 1 squared and so on. You end up with a big mess and really complicated. Just easier just to leave it like that. So again, the third one, third derivative at 1, which is e again. 3 factorial, which is 6, x minus 1 cubed. So that's how we get to e x minus 1 cubed over 3 factorial. Same with the 4, which is e over 4 factorial times x minus 1 to the 4. Simplifying that out, that's where we get to. And same again for the fifth derivative, which is also e times x minus 1 to the 5 over 5 factorial. And that's our Taylor polynomial. So that would be a very suitable answer to write. The Taylor polynomial of degree 5 at point 1 for e to the x is as follows. And this here would be a good answer. So what we're going to do now, we're going to check with a graph of e to the x and compare it with our Taylor polynomial to see if we get the same thing. And here it is. So the thick black line, that is our Taylor polynomial. And e to the x is this dotted line. Now we was asked to calculate at the point 1. So the point 1 is around about here. As you can see, it's very accurate to where we are. And it stays accurate all the way up the line, which is very good. And coming down the line, even at 0, it's still accurate. And only when it comes into the negative side of x, so minus x, does it start to tail away a little bit. And then here it starts to tail off in a completely different direction. It actually diverges all the way down to negative infinity. But as you can see, the values are pretty close. I mean, e to the x converges off to 0 eventually, to negative on the negative side. So that's all there is not close at all. But at the point 1, which is where we have to calculate it at, it's very, very accurate. So we can say that it's a success. So therefore we conclude that our Taylor polynomial is correct. T5 of x equals e plus e times x minus 1 plus e times x minus 1 squared over 2 factorial plus e times x minus 1 cubed over 3 factorial plus e times x minus 1 to the 4 over 4 factorial plus e times x minus 1 to the 5 over 5 factorial. You could write the numbers in here, which is 2, 6, 24, 120, but it's perfectly acceptable to write that. And that concludes the video. So thanks for watching. Any comments, leave below. As always, please remember to subscribe. Thanks very much.